Hey guys, making a short little immune system video for you. I'm going to try to keep this short. I know you guys have watched lots of videos on the immune system, but I really find that it helps a lot of students to draw it out kind of step by step and see how the first line of defense leads to the second line of defense, and then all that cell-mediated third line of defense with the B cells and T cells. So I'm going to go through that. Try to keep it short, but you can listen to me at 2 times speed if you want me to sound like a chipmunk and if you think you need to see it that quickly. But I would recommend grabbing just a blank piece of paper and trying to draw this out along with me, or you can wait till the end of the video and then draw the immune system steps by yourself. So let's start with talking about the pathogens themselves. So a pathogen, it could be a bacteria, virus, fungi, a parasite. It could even be a toxin that's introduced. And all of those things your immune system has to react to differently. So that's part of why these antigens on the surface of your pathogen are so important. Okay, so the antigens, you can remember pathogen with the gen goes with antigen. Those are going to be one and the same. The antigen is actually short for antibody generator. So what that means is it's the part of the pathogen that your immune system is reacting to. It's the part that your white blood cells are aware of and what they're going to be identifying that as a pathogen and not as self. Okay, so on your body cells, you actually also have self-antigens, and we'll learn about that with blood typing, that all of your cells, they have some little markers on the surface. They might be proteins, they might be sugar or carbohydrate molecules, but they're going to be signaling to the immune system that, hey, this is a part of your own body, this is a part of self, so you don't have to attack it. Or it could also be reacting, of course, if it's a pathogen. That's what your body or your immune system is going to look at and say, this is not something I recognize. This is something brand new, this antigen, and so I should destroy it. It's not supposed to be in the body. Usually that's a really good reaction, but if you have allergies, usually it's a reaction to antigens on the food that you eat. And for most people, your body is just not going to react to that. For some people, your body might react like it's something that's going to kill you. And then you get basically a very bad inflammatory response towards that. Same with if you have like seasonal allergies, you can get inflammation because you're breathing in or getting into your eyes these antigens that for most people would be harmless. Your body kind of overreacts to it though. Okay, so let's just zoom out here so we have lots of room. I'm going to start with talking about how these pathogens get into your body. So we're just going to start by drawing out, none of these are great. I'm just going to draw out kind of a little surface here that can be your skin. Sorry, there's other teachers bugging me with posts there. Okay, and we're going to draw a little Harry Potter style cut on the skin because we want a place for those pathogens to get in. This could be getting in through a mucous membrane to like your nose or your eyes or your mouth. So now we have a little entry point. This cut, it means that we can break through the first layer of defense with your immune system. Okay, so this was your first defense. And if you get a cut, we've already gotten through that. So these pathogens are going to sneak in here before the platelets are able to come and seal up that cut. Okay, and so as soon as we have some of these, actually I'm going to just copy all these pathogens in here so we can have a whole bunch of them. Okay, so as soon as we have some pathogens entering through this cut, your body needs to react to that and try to kill them as quickly as possible. Okay, and so that's when we hit this second line of defense. And the second line of defense we also often will call inflammation. Okay, so when you say the word inflammation, you probably think of swelling, redness. Both of those things have to do with bringing increased circulation to the site, because we want to have lots of platelets coming if there's a cut to try to seal up. We want to have lots of white blood cells coming to the scene, and so that's where that swelling and redness comes. The swelling can also help to immobilize a cut, meaning that, an injury. So if you like bang your knee on something and it starts to swell up, your body's trying to make it so you can't move that as easily, so you don't hurt it worse. And sometimes that's why we get pain as well. That's something your immune system is actually causing, so that you know where the injury is or where the infection is, and your body's trying to get you not to make it worse. But unfortunately, these are a lot of the symptoms we get from even allergies. And it's really your body trying to help, but it's not always very comfortable. Something else that's really important is the heat. So normally your body should be 37 degrees Celsius. And so if we're trying to kill a pathogen that's just entered, oftentimes those bacteria or viruses are successful at our human body temperature. They can live and divide really well at 37 degrees. So if we crank up the heat and you get a fever or you just get swelling and heat in that area, it's going to help to kill some of the pathogens. That's kind of the aim for your body, is to try to kill those guys with heat. The last thing, which is a bit more important for the rest of the stages, is we have the macrophages are coming in here. This is the only real cell that is active in the second line of defense. This whole inflammation response, this is what we would call non-specific. Okay, so it's not going to be different if it's a virus, bacteria, fungus, parasite. We're going to try all of these things first, because this can kill most of the things that will enter our body. Okay, so maybe let's say that this wipes out one of the pathogens, but it's not quite enough for the others. And bacteria are good at dividing really quickly. So let's say that they're just multiplying anyways. We have a ton of these pathogens around. Okay, so the part that's really going to help us here is these macrophages. Okay, so I'm going to bring one of the macrophages in here. Maybe he eats this pathogen that we just killed. And he might also eat this pathogen right here. Okay, so the way that the macrophages work is they sort of stretch out these little arm-like structures. It's going to wrap all the way around the pathogen and swallow it up inside, and then they just kill it with their digestive enzymes. But they do want to save these antigens on the surface, because those are identifying what pathogen we're looking at. Okay, so the macrophage is just going to kind of blindly eat up all of the pathogens that are there, but then the macrophage, he turns into an antigen presenting cell. Okay, so it's the same white blood cell that eats the pathogens. He turns into an antigen presenting cell, which we often call APC for short. So remember these antigens that he saved from the pathogen. The antigen presenting cell is going to push them out to the surface and present them kind of like a little flag to show the rest of the immune system what we're looking for. Okay, so it's going to be much easier after this point. If anyone sees this pathogen around, they're going to recognize all the markers on the surface, and your white blood cells can attack it much more quickly. This also helps your white blood cells to learn about what kind of pathogen is this. Is it a bacteria, virus, fungi? We're going to attack all of those things very differently. Okay, so after this point, as soon as we have an antigen presenting cell, we're entering what we'd call the third line of defense. Okay, so some things about this. It is very specific. Okay, at this point, we know what that pathogen looks like. We know what antigens we're looking for. we might be able to learn some things about how it's going to grow, divide, how it's going to attack the body, so we can have a more specific response to try to target it. This is also cell-mediated, which means that we're going to be involving lots of other white blood cells. By specific, we mean it targets that pathogen specifically. We don't want to have things like swelling, pain, a fever going on for a really long period of time, especially if it's not actually helping to kill the pathogen. So we want to have a specific response so that your body isn't feeling all of these inflammation kind of symptoms, but your body can actually just target that pathogen and only that. Some of these inflammation things could damage your body long term as well, so we want to have that specific response. We also sometimes call this the adaptive part of your immune system. If something can adapt, it means it can change in response to its environment. So your white blood cells, they can change their behavior to target whatever pathogen we're dealing with. Okay? So the first part of our immune system here, that's going to talk to your the antigen presenting cell, is something called the helper T cell. Okay, and the helper T cell is going to help the rest of the immune system to learn about that specific pathogen. It's the only one that really has to interact with the antigen presenting cell, but it can tell everyone all of the information about that pathogen. Okay, so basically the helper T, his job is to tell everyone, so I'm going to tell everyone to fight the pathogen. Okay, and that's his whole job, is just to spread the word. Later on, we'll talk about some of these helper T cells. They're going to become a long-term memory for your body as well, so that you can, once your body's fought some pathogens, it can remember them long-term, and we can have a faster response. Okay, so from the helper T cell, let's talk about, actually, I'll tell you why he's called a T cell. So any of our cells that are a T cell, T is for thymus. Okay, so if you remember when we talked about the lymphatic system, one of the organs was your thymus, which is right close to your throat. And the thymus is where all of those T cells are going to go to be trained and to be matured. Okay, so oftentimes your antigen presenting cell, it's going to travel to a lymph node, which is a part of your lymphatic system, and that's where often we'll have white blood cells gathering to be trained. And so that's where the helper T meets the antigen presenting cell. It travels to the thymus to teach the other T cells. But while it's in the lymph node, let's talk about how it's going to teach the B cells. Okay, so you guys might already remember from before, your B cells, the big thing that they like to make is antibodies. So this guy is going to make antibodies that are specific for the pathogen. Okay, so they're shaped so that they can only fit the antigens that have been presented to them by the antigen presenting cell. Okay, so he's going to start to basically become a little factory for these Y-shaped proteins, and I'm making these little kind of triangle-shaped thingies on the ends. That is what's going to grab on to the antigen on your pathogen. Okay, so these guys become kind of like heat-seeking missiles. They're going to be looking out for if any pathogens have creeped down this low. Okay, and you can see that they're a similar shape to the antigens on the surface. Okay, so once they find some pathogens, they do a few things to them. They're going to clump them up And that clump, when we clump them up, we call that agglutination. Okay, so what the antibodies do, I'm just going to make a little list here. They agglutinate the pathogens, so they clump them up. The clumping, it makes it easier for a macrophage to come in and gobble them up because they're all in one location. It doesn't have to hunt around for them anymore. So I'm going to draw the macrophage coming in here to eat this nice clump. Okay, and the other thing that the antibodies are doing is they're doing something called opsonization. Okay, so they opsonize the pathogen clump, which means that it makes it really delicious for the white blood cells. Is kind of the best way to think of it. It's kind of like if you have popcorn at the movie theater. You're like, yeah, okay, I mean, popcorn is popcorn, it's not bad, but as soon as you put like butter and salt on it, it's just irresistible. And so when we opsonize the pathogen clump with the antibodies, it draws the macrophages over. They come swarming because it signals to them that there's something good for them to eat. The other things that the antibodies do is while they're trapping the pathogens, they immobilize them and they inactivate them. Inactivate the pathogen. Okay, so while they're trapped here with the antibodies waiting to get gobbled up by a macrophage, they can no longer divide and keep taking over the body. Okay, so the problem is sort of solved for those pathogens and they'll eventually get destroyed. Okay, so the B cell, super important. We want lots of these antibodies because they help the immune response for so many reasons. Okay, while the B cells are working, they're going to divide and make more of these little factories. And once they're done, their response, much later on, they're going to make some memory B cells as well. Okay, and those memory B cells, they'll remember that pathogen long term. I'm going to put little nerdy glasses on him so that we remember that he's smart. I know, kind of a stereotype, but he is always going to remember how to make these specific antibodies against the pathogen. Okay, so that's really important because even once this immune response is totally done, we're going to have some of these intelligent memory B cells that if they ever run into that pathogen again, they'll be able to start pumping out antibodies immediately. They don't have to wait for the macrophage to swallow it and to tell the helper T cell what's going on. Okay, they can get right down to business. All right, so that's about it for the B cells. Now let's talk about another type of T cell that's really important. Okay, so this next T cell is called a killer T cell, and this is basically the assassin in your immune system. So he's going to look for, let's make some other human tissue cells just on the side here. This could be skin, it could be part of your epithelial tissue, who knows. But let's say that most of these cells are happy, they're healthy, and they're identifying as part of your own body. So they'll have some self-antigens. But let's say that just one of these guys has become infected. Okay, so it has some of these pathogens inside. Usually this is going to be for a virus. If we have a virus that infects some of these body cells, the infected cells, they're going to show some signs of distress that they're not healthy, and some might actually even push the antigens to their surface. Okay, so this is sort of a signal for that cell to say, like, please destroy me. I don't want to infect my healthy friends that are beside me here. Just kill me. And the killer T cell, he kind of gives a little mercy kill to that infected cell. It's for the good of the rest of the body to keep it healthy. Okay, so I know this looks really graphic that I'm drawing a little gun here, but the way the killer T cell kills is it shoots these little proteins. It's like it's shooting from a little gun. It shoots that infected tissue and it makes it explode. Okay, it kind of rips a hole into it so that that cell explodes or it lyses. And that's going to kill all of these pathogens that are living inside as well. Okay, if we're dealing with a bacteria or, a bigger kind of a cell-like pathogen, the killer T cell might kill it directly as well. Okay, and then it'll be the same way, it'll cause it to rip open, explode. So it can only do that to pathogens that have a cell wall. If it's a virus, unfortunately, that can't be killed directly. We'd have to just kill the infected body cells. Your killer T cells, they're also the ones that we kind of have hopes that it'll help with some cancer treatments because they can hunt for infected body cells like tumors as well. Okay, so your killer T cell there is doing quite a bit of damage. And so it's important for your immune system to have a way to stop all of this eventually. Okay, so let's say that we're kind of running out of pathogens at this point. We've solved the problem pretty well. Eventually, your helper T cell is going to activate a cell called the suppressor T cell. Okay, and I made him look like a stop sign on purpose because this suppressor T cell, his main job is to eventually give some feedback to the killer T cell as well as to the B cell over here and tell these guys to kind of calm down once the immune system has defeated the pathogen. Okay, and so we want that to happen because especially if you think of the killer T cell, how he's damaging tissues here, the B cell is using a ton of energy to make antibodies. We want to save energy and not cause damage to the body. So the suppressor T cell will stop the immune system response once all the pathogens are gone. Okay, one very last thing that I mentioned a little bit is that once this response is totally solved, these helper T cells can become memory cells as well. Just like this smart memory B cell here, that's always going to remember the pathogen. We can have some helper T cells that become memory T cells. He's a memory T cell, and he is also always going to remember the pathogen. Okay, and so this is really important, especially for that helper T cell, who is so important in starting that whole immune response. If we can keep some of those guys around who remember the pathogen long term, we're going to have more success fighting it in the future. Okay, and this is a lot of how our vaccines work as well. Once we have these memory cells built, if you're exposed to the pathogen for real, if you were actually infected with something after being vaccinated, those memory cells can kick into action right away. We don't have to go through inflammation and all these steps up here. Usually they're going to target that specific pathogen and defeat it really, really quickly. So one last thing that I was going to mention is just an issue that you can have with your helper T cells. So later on, if you haven't read all the notes yet, you might, or you'll run into learning about something called HIV, which I know it looks like a creepy kind of spider here. This is a virus that is called a retrovirus, and it invades cells, and it uses the cell machinery to pump out more of that virus. HIV is really especially terrifying because it targets helper T cells specifically. It will replicate a whole bunch of itself inside the helper T cells, and it infects other helper T cells in the body, and eventually it wipes them out. Okay, and so eventually HIV is going to kill that helper T cell, And then that's going to stop all of these other steps of the immune system. Okay, so you can imagine how hard it's going to be for someone with an HIV infection to be able to fight even just really simple pathogens after that.